What's up, ladies and gentlemen, FFDev here, and in this video I'm going to be showing you how you can create some terrain generation, like basically just generate some terrain using C++ and SFML and a tile sheet. So to start things off, I'm just going to run it real quick, show you what I created. You can change the size of this or whatever you want. There's a grass tile which has dirt on it, then there's a dirt tile, and there's a stone tile or rock tile, whatever you want to call it. I didn't have this one tiled perfectly where it would look seamlessly whenever you're looking at it, but it serves its purpose. So first things first, I'll show you the classes I use to do this and how to do it. So if you want to get started yourself, first of all, you just want to have your basic SFML set up with your while loop in here. But this let's see, I'll show you here with your while loop while window is open, you know, the basic stuff, and I'll show you where to get started. I'll show you what the tile class looks like. So you'll want to create a tile class and make sure you include your SFML graphics.hpp in the tile class in the header file, and make sure you always have pragma once on so you don't double include stuff. So I started it off with the tile class by giving an SF sprite, you know, tile sprite, that's what I named it. Every tile is going to have a sprite. Then I created a function to set the tile sprite, which takes a reference to a texture. And then I also created a function to return a sprite called getSprite. And I also created one called setPosition. Now I'll show you in the C++ part what this looks like. It's not complicated at all. Feel free to pause the video if you need to pause it. So the text set tile sprite just takes a reference to a texture, and then it sets the texture to that reference of the sprite. Then you have one which returns the tile sprite called getSprite. There's nothing to it, and setThePosition takes the sprite and sets its position to the X and Y. Alright, now that you see what this class looks like, I'll take you to the main class and explain what's going on. Here's where I declared my window, my render window for the video mode, 1920 by 1080. So in the main function, the tiles on the tile sheet that I have are 32 by 32, so I put the tile size as 32, but if they were different size, you know, you would have to put like the tile size width and the tile size height. So what I did there was I put a constant integer, so I can't change this, so this stays the same. It's 32, and the number of tiles I want is 8 by 8. And you'll see where I set this up. So I also created a game view, a different view called a game view, because 32 by 32 tiles, those are really small, especially if you're in 1080p. So I kind of created a view so I could zoom in, and it wouldn't be so small on the screen, that way you guys could see it. And this is just my event, you know, standard stuff. But here's where I started creating the assets, and I'll explain how I did it. So I created an SF texture called spritesheet. So this is a texture, but then I went to spritesheet, load from file, src, you know, source folder, because that's where I have, I'll show you right here, my tileset.png. And I loaded it into there. And also, if you guys want to follow along, I'm going to include my tile set in the description, a link to it in GitHub. That way you guys can play around with it and understand what's going on. So here's where I created an array. I usually do vectors, but for the simplicity of the video, I just created an array, kind of like I showed in my last video. There's a couple of ways to do it. So I created an array of tiles. I named it TM for tile map. And I created its size, you know, 8 by 8. Or whatever the number of tiles is. So it's easy to change, it's just changing these numbers right here. Then I also included a vector here, as you can see, and I created a vector of textures to store my textures. There's different ways to do this. You'll probably see some tutorials using vertices, but for the simplicity of this video, I used an int rect. And what I did was basically I created two for loops where y is initialized, this is for the height, y is initialized to 0, and if y is less than the sprite sheet, that gets size y. So basically if it's less than the height, y plus equals tile size, which will increase, you know, go down on the y axis by the tile size, which is 32 for the next one. Then I created a for loop for that x, you know, which basically does the same thing except on the x-axis, which checks the width. So anyways, as it's running through, you'll get an int rect here. I use an int rect, which basically the x and y, this defines its top left corner, and this defines its bottom right corner. The tile size does. And because it's it's a square, I use tile size twice. But if it wasn't a completely square tile set, you know, maybe 32 by 16 or anything different than being symmetrical, you would have to add two different values here. You could post in two different numbers, maybe tile size width or tile size height. But anyways, after I got that, after it creates the rectangle where you want your tiles, it creates a default texture at SF texture. And this texture then loads from file using a SFML function. You'll go to the sprite sheet, which we created here, which holds all of our tiles, and we'll copy to image wherever this rectangle is at. And this defines the rectangle as we get through a for loop. And then once it copies that texture, it'll push it back to our tile textures vector. And it completes until the whole tile sheet's done. If you take a minute to analyze it, you'll be able to understand it. If you're still having trouble, you can copy this and paste it in ChatGPT and ask it what's going on here, and ChatGPT will gladly tell you what's going on. Then, here's a little bit of magic. This is where I generated the terrain itself. After we have our textures, I just created an X, you know, and a Y for loop nested. You can change the order depending on how you want the terrain to generate. Really doesn't matter too much. So it works similarly, but I put the tile size, you know, for the condition. I'm checking to see if X is less than the tile size, than the number of tiles, because we need to get its position, you know, in pixels. Anyways, I'm just doing plus equals tile size. There's different ways I could have done this. I could have plus equaled, you know, by 1 and then multiplied it by tile size here, but this is just the way I chose to do it. And to make sure that, because the way I did it, it probably looks a little complicated, to make sure that I get the correct index in my array, as it goes through, I divide by the tile size, since X is going to be plus equal by 32. So like if it's 1, let's say it's 32, then you do 32 divided by tile size. You know, 32 divided by 32 is 1. Let's say it's 2. 64 divided by 32 is 2. You see what's going on here? Probably did it a little bit of a difficult way, but basically I when it goes through, I put if the y coordinates is equal to 0, so it's the top tile, we're going to set the tile sprite to the tile texture's first index, which is grass tile. Then we're going to set its position to that. And because we don't need to, you know, we want it to actually be the X and Y position, we'll just put it to X and Y. If I just added X and Y by 1, I would have to multiply it, right here, I would have to multiply it here by the tile size to make sure it's in the proper position. So there's some drawbacks on either way you do it. Then on the else if, I checked if the Y is equal to 32, which is down below because the way SFML works. The lower you go, the higher the Y value is. So if the Y position is 32 or 64, somewhere in there, it's greater than 32 and it's less than or equal to 64, then this is going to be the dirt texture. And then finally the else statement, if it's below that, it's going to be the stone texture. And this is just my basic setup, you know. This is where I actually set my game view size to make it small enough to see. And I set the center of it to the very center by setting the center to the tile size divided by the number of tiles, or the tile size times the number of tiles, and then divide that by 2 so I get in the center. And did the same thing on the Y, so the X and Y, and then I set the view to the game view. And this just handles the closing events, and this handles the drawing. Pretty simple. Let's set X equal to 0, so X is less than the number of tiles, X plus plus, then same with Y. Then we just do the window.draw tile map xy.getSprite, and then we used our getSprite function here to get the sprite. And so whenever we run it, we get this right here. And because of the way I set it up there, we can easily change our number of tiles, let's say to 12. Now we run it, and it's going to be set to the center, but that's going to be way too big, at least for the screen right now. So we'll set it to 5. And there you go, there's a smaller version. And basically this video shows you how to get started with terrain generation, and I'll hopefully give you guys an idea on how it works. And if you guys want to implement it yourself, the tile sheet will be in the description, link on the GitHub page. Yeah, so I hope this helps you guys. If you guys like this video, hit the like button, hit the subscribe button if you haven't already, it really helps me, and I'll see you guys in the next video. Bye.